This is the video presentation of percent protein, Analytical Services Method number 4. This percent protein method is a proximate analysis test based on the Dumas method, which determines the percentage of crude protein by combustion, thus freeing the nitrogen in the sample. The nitrogen is converted to crude protein by applying a mathematical factor. Keep in mind that non-protein nitrogen will also be measured. The method described here is based on the official AOCS method and the manufacturer instructions. A wide variety of materials may be analyzed, including but not limited to meats, processed foods, feeds, oilseeds, fertilizers, and soils. Before attempting this technique, it is mandatory to read the test method in its entirety. This presentation is simply an overview or a summary of percent protein. The good laboratory practices associated with safety and personal protective equipment represented in this video are simply the safety requirements of the FAPC Analytical Services Laboratories. Furthermore, all samples received by Analytical Services are considered to be for testing purposes only and not for human consumption. Therefore, food safety and handling procedures do not apply. We urge you to determine what specific good laboratory practices and particular safety requirements are necessary for your own applications. Some of the recommended guidelines for good laboratory practices include: take measures to maintain the integrity of the samples throughout the process by limiting exposure to air and non-suitable storage temperatures, wearing gloves when handling samples and items associated with the test to prevent cross-contamination. Oil, moisture, or any other material on bare hands can affect the sample integrity, thus resulting in inaccurate data. Keep samples clearly labeled from preparation to disposal. Record observations at the time they are made. Exercise safety precautions at all times by using the specific safety supplies listed in the method. The necessary supplies for percent protein are the LICO TruSpec nitrogen determinator, equipped with analytical balance, external computer system, and LICO software. Spatula, tweezers, cup and cap holder, large tinfoil cups for low moisture samples, tin capsules, 6 mm for liquid or high moisture samples, medium quick caps for dry samples only, and lab coat. There are 3 gases that are necessary for the LICO TruSpec to operate properly. Oxygen, ultra-high purity grade, or UHP, is the combustion gas. Helium, ultra-high purity grade, or UHP, is the carrier gas. And breathing air operates the autosampler. For a standard, use the EDTA calibration sample supplied by LICO, calibrated and traceable with a minimum purity of 99%. The EDTA standard must be recalibrated annually, or a new standard must be ordered unless the nitrogen result remains within plus or minus 1% of the manufacturer's reported value. The use of a control sample or a standard reference material is strongly recommended. The LICO TruSpec software is configured in such a way that all of the instrument checks can be performed through the computer. All analysis runs can be logged and controlled, and calculations are automated. When not in use, the instrument is left on. The gas flows automatically revert to standby mode when the instrument is not in use. If for any reason the instrument has been without power, it must be turned on and equilibrated until the furnace reaches a temperature of 950 degrees Celsius before use. To ensure that the overall system is operating satisfactorily, a system scan is performed daily or with use. From the Diagnostics menu, select System Check, then Start. Check the results of all systems. The circle in front of the system name should be green, and in the Results column, all systems should indicate Passed. In the event that any of the systems fail, maintenance or repair on that particular item is probably necessary. In addition to the system check, the flow and combustion areas of the system must be checked for leaks daily or with use. A gas leak will prevent the LICO from operating properly, if at all. Oxygen is the combustion gas. A whole O2 leak check simply means that every part of the LECO that carries or contains the pure oxygen gas will be checked for leaks. To perform the whole O2 leak check, go to the Diagnostics menu and select Leak Check. The leak check screen will appear. Click the whole O2 button at the top left portion of the screen. Click Start to perform the whole O2 leak check. System pressure is monitored in the chart in the middle of the screen. When the test is complete, the results column should indicate Passed. If the results column indicates Failed, there is an oxygen leak in the system and it must be located and repaired. Helium is the carrier gas. A whole helium leak check simply means that every part of the LECO that carries or contains the helium gas will be checked for leaks. To perform the whole helium leak check, select the whole helium, or HE, button at the top center portion of the leak check screen. Click Start to perform the whole helium leak check. System pressure is monitored in the chart in the middle of the screen. When the test is complete, the results column should indicate Passed. If the results column indicates Failed, there is a helium leak in the system and it must be located and repaired. Only one instrument method has been established and calibrated on the LECO TruSpec. Method 3908 must always be used for protein analysis. Before beginning any testing, a protein factor must be selected based on the sample type. This chart shows the sample matrices and the recommended protein factors. The protein factor is the number that will be multiplied by the percent nitrogen result to convert it to crude protein. In addition, this chart suggests the type of combustion container to be used when weighing specific types of samples. The container can be a critical aspect of determining accurate sample weights because of potential leakage and weight variation. The first analytical step is blank calibration. Blank calibration is used to calculate the blank or baseline. Sometimes this is called the blank area. Blank calibration calculates the instrument blank and adjusts the nitrogen area of the analysis accordingly. The system blank should be determined on each analysis day by performing a blank calibration before analysis. A blank should be analyzed and the blank calibration set prior to drift correction. Analyzing a series of blanks allows the operator to run an analysis without burning a sample. This is done in order to obtain a series of data to set the blank area. Before a blank is analyzed, a sample labeled blank must be entered into the spreadsheet. This procedure is called blank login. From the Samples menu, select Login. The Sample Login dialog box will appear. Click the drop-down arrow in the Sample Name selection box and select Blank from the list. Leave the default value in the mass box at 1.000. In the Repetitions box, type the number of blanks to be analyzed. This number should be sufficient to obtain 3 consistent blank values once the instrument is conditioned. Approximately 10 blanks will normally satisfy the minimum requirements for conditioning and setting the blank nitrogen area. The method box will default to test method 3908. Do not change it. In the operator box, enter the name of the person performing the analysis. In the protein factor box, enter the appropriate protein factor for the samples to be analyzed. The protein factor for the blank must be the same as for the samples. No other values are necessary for the blank login. All values can also be entered directly into the spreadsheet using the Enter key to add lines. Verify that the first position of the blank corresponds to the next position on the auto sampler carousel, as indicated by the numbers in the sample spreadsheet. Select the Analyze button at the top center portion of the screen to begin the blank analysis. Once all of the blank runs are complete, highlight the last 3 blank run lines in the spreadsheet to view the statistics. The statistics appear in the lower right of the screen when more than one line is highlighted. The standard deviation must be less than 0.1 and the ideal nitrogen areas will be less than 1. This column in the analysis table is the nitrogen area. With the blanks highlighted from the configuration menu, select blank. The method blank screen will appear. The action column must read include, and the detector column must read nitrogen. Select OK to replace the previous blank value. The second analytical step is drift correction. A drift correction is performed on each analysis day. Drift correction is used to adjust the original calibration response to match the current instrument response. From the Samples menu, select Loggin. The Sample Login dialog box will appear. Click the drop-down arrow in the sample name selection box and select EDTA from the list. Now the EDTA can be weighed. Place a large tinfoil cup on the balance, close the doors, and tare the balance. Weigh approximately 0.3 grams of EDTA on the tinfoil cup. Carefully remove the tinfoil cup from the balance. Twist the foil closed into a narrow teardrop shape. Place it back on the balance and close the balance doors. When the weight has stabilized, press the button at the bottom right on the balance. The weight will be automatically recorded. The method box will default to test method 3908. Do not change it. In the operator box, enter the name of the person performing the analysis. In the protein factor box, enter the appropriate protein factor for the samples to be analyzed. The protein factor for the EDTA standard must be the same as for the samples. No other values are necessary for the EDTA login. All values can also be entered directly into the spreadsheet using the Enter key to add lines. The weight can also be entered automatically from the spreadsheet view using the steps described previously. Verify that the position of the EDTA standard corresponds to the next position on the autosampler carousel as indicated by the numbers in the sample spreadsheet. Drop the tinfoil cup containing the EDTA standard into the corresponding sample position as indicated by the numbers in the sample spreadsheet. The tinfoil teardrop should be small enough to freely fit in the carousel slot. Repeat this process for 4 more EDTA standards. A minimum of 3 must be analyzed to set the drift correction, but the first 2 help to stabilize the instrument. Select the Analyze button at the top center portion of the screen to begin the EDTA standard analysis. This entire process can also be performed while the blanks are running, making it unnecessary to select the Analysis button. Once all of the EDTA standards are complete, select the 2 EDTA run lines in the spreadsheet that are closest in result and nearest to the end of the run. Highlight the results to view the statistics. The statistics appear in the lower right of the screen when more than one line is highlighted. Select the line combination with the lowest %RSD value to be used for the blank. The %RSD is shown as RSD on the screen. The %RSD must be less than or equal to 0.3, and the nitrogen % result must be within the manufacturer's certified range. Remember, the blank run used the nitrogen area. The drift run uses the nitrogen %. From the configuration menu, select Drift. Select Drift again from the flyout menu that appears. The method drift screen will appear. The action column must read Include, and the detector column must read Nitrogen. Select OK to replace the previous drift correction value. Samples will be entered in the same way as blanks and drifts. Consult the sample variables chart to determine what type of container to use when weighing the sample. Low moisture samples should be weighed in the tinfoil cups, just like the EDTA drift material. High moisture samples, such as meat, should be weighed in the tinfoil capsules. It is important to note that before a sample is analyzed, it must be properly prepared so that an accurate test result can be obtained. This is achieved by homogenizing the sample. Homogenization ensures that all of the sample material will be of consistent content throughout and suitable for analysis. For details, please refer to Preparation of Test Samples, Analytical Services Method Number 1. All samples must be analyzed in duplicate or triplicate. Samples may be prepared and entered directly in the sample spreadsheet while blanks or EDTA standards are running. Now we will weigh a meat sample using the tinfoil capsules. From the Samples menu, select Loggin. The Sample Login dialog box will appear. Click the drop-down arrow in the sample name selection box and type in a sample ID. Use tweezers to open and form the tin capsule and place it in the holder. Place the holder on the balance, close the doors, and tare the balance. Before weighing samples, verify that they have reached room temperature. Otherwise, the measured weight will be inaccurate, making the percent protein value incorrect. Weigh approximately 0.3 grams of sample in the container. When the weight has stabilized, press the button at the bottom right on the balance. The weight will be automatically recorded. The method box will default to test method 3908. Do not change it. In the operator box, enter the name of the person performing the analysis. In the protein factor box, enter the appropriate protein factor for the samples to be analyzed. Type any additional sample information into the description and comments boxes. All values can also be entered directly into the spreadsheet using the Enter key to add lines. The weight can also be entered automatically from the spreadsheet using the steps described previously. Drop the tin capsule containing the sample into the corresponding sample position as indicated by the numbers in the sample spreadsheet. Repeat this process for all remaining replicates and samples. If a run is not in process, select the Analyze button at the top center portion of the screen to begin the sample analysis. Once all of the replicate sample runs are complete, highlight the 3 replicate runs in the spreadsheet to view the statistics. The statistics appear in the lower right of the screen when more than one line is highlighted. The percent relative standard deviation must be less than or equal to 5. The percent RSD appears as RSD on the screen. If the percent RSD exceeds plus or minus 5%, reanalyze the sample in triplicate. Notice that the sample results are in the percent protein column. With samples, we look at percent protein, unlike blanks, which refer to nitrogen area, and drift runs that refer to percent nitrogen. Highlight the lines of any analyses that you would like to print in a report. Right-click and select Print. The LEGO software groups sample IDs together and prints a report with statistics for each sample group. When applicable, the measurement uncertainty should be included with the result.